Next, detail, take all the detail in whatever and then we can discuss and maybe from next week. हाँ वो करना पड़ेगा तो अभी वही प्रपोजल दिया ना हमने वो टीका नहीं दैट IGBT दैट टीका हाँ हाँ SSDC ठीक 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 है
गौरव सरप्राइज ना
audio only for
part of our work groups. I grabbed her. I didn't let her go.
పెట్టండి మెయిల్ రజత్కి ప్లేస్ అనేసి ఇన్వాయిస్ అనేది పెట్టేసి ఫామ్ ఇచ్చాడు కదా కమర్షియల్ ఇంకా అనేసి ఇచ్చాడు
Ladies and gentlemen, wishing all of you a very good morning. And I welcome you all to the conference on power electronics. I hope all of you have registered, had a cup of tea or coffee, maybe some refreshments. And we will begin the plenary inaugural session very soon. We are just waiting for the chief guest. He's going to arrive in just a couple of minutes, and then we shall begin. Thank you so much. Without much ado, let us commence the plenary inaugural session. May I invite our esteemed dignitaries for the ceremonial lamp lighting and the official inauguration of the conference and exhibition. May I please request our chief guest, Dr. D. Sai Baba, Joint Secretary, Ministry of Power, our guest of honor, Ms. Sunita Verma, Joint Secretary, Ministry of Electronics and IT, Mr. Vivek Mahajan, Vice President, Infineon Technologies, Dr. Leo Lorenz, President, European Center for Power Electronics, Mr. Hitesh Bharadwaj, Business Head, Semiconductor and Devices, Mitsubishi Electric India, Ms. Petra Harberger, President, Messago Messi Frankfurt, and Mr. Raj Manik, Executive Director and Board Member, Messi Frankfurt Asia Holdings Limited, to please do the honors. And with that, the conference and exhibition has been officially inaugurated. Can I have a round of applause, ladies and gentlemen? Thank you so much to our dignitaries for doing the honors. I now request Mr. Raj Manik to please escort our dignitaries on the stage. Our chief guest, Dr. D. Sai Baba, our guest of honor, Ms. Sunita Verma, Dr. Gaurav Majumdar, IEEE Fellow, Senior Fellow, Mitsubishi Electric Corporation, Dr. Leo Lorenz, President, European Center for Power Electronics. I request all of you to please come up on stage. I request all of you to please take your seats. Thank you so much. And now, to deliver the welcome address, please join me in welcoming Mr. Raj Manik, Executive Director and Board Member, Messi Frankfurt Asia Holdings Limited.
Good morning, ladies and gentlemen. I welcome you all to the inaugural edition of PCIM Asia New Delhi Conference. A very warm welcome to our esteemed chief guest, Dr. D. Sai Baba, Joint Secretary, Transmission and Coordination, Ministry of Power, Government of India. Thank you so much for joining us today. Our esteemed guest of honor, Mrs. Sunita Verma, Group Coordinator, R&D, Joint Secretary, Minister of Electronics, Information and Technology, Government of India. Thank you so much for joining us today. Thank you for taking the time to be with us all today. I also welcome and thank our esteemed speakers, exhibitors, partners, industry delegates, and friends from the media. PCIM has a long, proud legacy since the foundation in 1979, and today stands a globally recognized platform for power electronics and key application areas, with flagship events taking place annually at Nuremberg in Germany. Organized worldwide by Messago Messi Frankfurt GmbH, it has evolved into a hub for premier knowledge exchange, sharing cutting-edge innovation and industry collaboration. As the event theme states, the agent of change for the Indian power electronic industry, this launch edition of PCIM India is both significant and timely. As the nation advances with a strong impetus on energy transition, electrification goals, power electronics stands at the center of the transformation of this key enabler. The surge in demand for high-end power electronics is led by enormous opportunities opening up in key application areas that have been and will remain at the forefront of significant infrastructure development and investment. With the first focused edition of the conference, or the first Indian focused edition of the conference, we aim to enable deeper collaboration between global innovators, Indian industry, key application areas, government policymakers, and the premier academia. Over the next 2 days, you will experience high-quality technical papers, strategic keynotes, panel discussions, and innovation showcases from more than 50 exhibitors with over 500 participants from India and abroad. This platform truly serves as a bridge for the knowledge exchange and impactful networking. I once again thank each one of you to join us at the launch edition and wish you all an engaging conference and meaningful takeaways. Thank you very much.
Thank you so much, Mr. Manik. And now for the opening address, we welcome Dr. Leo Lorenz, President, European Center for Power Electronics, and also member steering committee, PCIM Asia New Delhi Conference. So, can I have a round of applause for Dr. Lorenz?
Dear Excellencies from ministries, dear experts from industry and academia, colleagues and friends, ladies and gentlemen. I'm very happy to welcome all of you to the first PCIM here in New Delhi. This is a premiere, and we are very pleased and honored establishing the PCIM here in India. India, by sure, is a very important marketplace on the threshold of a great future development. Our future is driven by two important development trends. First, we have to establish a sustainable economic development along with a sustainable environmental impact. Sustainable economic development is driven by innovation. Frequently, we need to launch new products on the market to stimulate the economic growth. For a sustainable environmental impact, we need to install a life cycle assessment and circular economy. The PCIM is pioneering both aspects. It's a technology platform offering an open discussion forum for power electronic development among experts from industry and academia. The PCIM conference and exhibition is having a long history for displaying and discussing applied power electronics close to the real application in the field and industrial needs. Companies are eager to use the PCIM for displaying new products on the market, research centers and universities showing future development trends, and professionals learn from expert discussions. Today, we are in the progress of electrifying the world. This is a great news for our power electronics industry to provide the enabling technology for transforming the world into a new direction, facilitating a sustainable economic development of the country and a better life for the growing number of population. Especially in India, there is a great development potential for power electronics. Just to give you one number, from $2.8 billion today to $4.5 billion in 2032, which is an average growth rate of significantly more than 5%. Today you are having already many very competent big players here in the country, in addition to all the foreign companies investing in this future domestic market. What I learned in the last few years, there has been a tremendous investment in the semiconductor industry, including power devices based on new wide bandgap materials with relevant packaging technologies provided by major incentives from the government. You have world-class academic institutions with excellent research programs, including active global university programs and industry collaborations. All of this is an excellent prerequisite to become a major player on the world market in this technology sector. Along with the transformation of the world to meet the environmental impact, considering the global warming potential, there are many new business opportunities driven by innovations. Therefore, in the future, power electronics research and innovation will be measured, of course, on the overall system performance, including efficiency, power density, reliability, lifetime cost, etc., but also on design for sustainability, including considering circular economy, the damage of the ecosystem, and resource availability. The big topics we have to satisfy in terms of technology innovation today and in the future are the mobility sector. This is including all transportation vehicles on the road, rail, air, and water. The energy sector, the transformation from natural resources to renewables, including storage capabilities and grid stability, ICT and data center, including cybersecurity, smart home and office and the digital factory, AI and digital twins, from the design of power converters to the production, the application in the fields, including predictive maintenance, up to self-learning final processes. For all these segments just mentioned, we have to provide solutions and innovations in the whole value-added chain, from new materials to power electronic components, smart and scalable power electronic building blocks, and complex system solutions with communication interfaces. Many questions along with the power electronic development trend, providing technologies for electrifying the world of the future, are topics to be addressed, demonstrated, and discussed during the PCIM conference. As the PCIM is very close to the real-world application, bridging industry and academia on a worldwide scale, we strongly believe to facilitate the power electronic development also here in India. For me, it's great to see that India is already doing an outstanding job in many fields of applications I have just mentioned before. We all know power semiconductor devices are the raw material of the future and a driving technology for the future development of power electronics. Therefore, the milestone you set here in India in this technology is key for the development. Along with this tremendous, fast-growing power electronic development on a worldwide scale, the PCIM became a leading technology platform for an open exchange of expert knowledge. Now, having a quick look on the PCIM conference this year, I am very happy to learn that in our program we are covering several fields of applications along the big topics I have just mentioned before. Conference highlights will be the keynote presentations during the plenary session this morning, excellent technical presentations covering renewable energy technologies, e-mobility on road and rail, outstanding presentations on power devices, packaging technologies and power converters for e-mobility, data center and motor control. On top, we are offering 2 tutorials provided by Mitsubishi Electric and Infineon Technologies. I can promise you that during this year's meeting, you will learn a lot about innovations on new materials, new components and power conversion systems. You will be inspired with new ideas for your everyday work back in your office, and you will have the chance to actively participate in expert discussions. Thank you so much for coming and joining us. I wish you have a nice and successful conference during these 2 days. Thank you so much.
Thank you so much, Professor Lorenz. And now our first keynote, which is on advanced power semiconductor technologies and challenges for pursuing carbon neutrality and sustainability. Please welcome Dr. Gaurav Majumdar, IEEE Fellow. He entered IEEE ISD Inaugural Hall of Fame and Senior Fellow, Mitsubishi Electric Corporation. Can I have a round of applause, please?
Thank you for the introduction, and thank you to the audience for being here today. As I said, I'm Gaurav Majumdar, an IEEE Fellow, originally from India. I graduated from IIT Delhi and have spent several decades living and working in Japan with Mitsubishi Electric. I hold a PhD from Kyushu Institute of Technology, and I'm a naturalized Japanese citizen, formerly known as Suzuki. The topic of my discussion speech is shown on the program, and I look forward to sharing my thoughts with you. Okay, we're back. Advanced power semiconductor technologies and challenges for pursuing carbon neutrality and sustainability. Next one. So the keynote will cover the following 4 items. Next one. Global electricity consumption has reached 30,000 terawatt hours per year, and demand is still rising. The chart on the left shows that most of this electricity is still generated from coal and natural gas, with renewables growing but not fast enough to offset fossil fuels. The 2023 breakdown on the right makes this clear. Coal and gas together supply more than half of global electricity. Wind and solar, despite rapid expansion, contribute only about 15% combined. As a result, annual CO2 emissions now exceed 37 billion tons, increasing by more than 5% each year. Although global electricity consumption is around 30,000 terawatt hours per year, as I said, but producing it requires 85,000 terawatt hours, with significant energy losses operating before it reaches the users. At the power plant stage, about 60% is wasted heat, and additional losses occur during transmission, distribution, and totaling over 55,000 terawatt hours annually, plus an extra 4,500 terawatt hours lost on the user side. The IEA estimates that up to 15% of electricity could be saved through more efficient appliances and systems. Improving efficiency in generation, transmission, and usage is crucial for reducing waste and emissions. This slide outlines how to reduce carbon emissions and promote sustainability in the electricity sector. First, we need to increase our use of renewable energy sources like solar and wind. Next, we should improve energy conversion, transmission, and storage using efficient technologies such as HV. On the consumption side, continuing to electrify transportation, industry, and infrastructure will lower our reliance on fossil fuels. Lastly, since many units, equipment, and systems rely on power electronics technologies, such as inverters and converters, improving their efficiency is crucial. In summary, combining clean energy with electrification will help us achieve carbon neutrality and keeping efficiency, while keeping efficiency a priority. Next one. This slide underscores. Next slide, please. Yeah. This slide underscores the scalability of renewables for global decarbonization. Deploying solar generation over only 2 to 5% of the Sahara Desert could theoretically supply current global electricity demand, demonstrating the upper bound of solar source potential. Achieving IEA NZE targets will rely on extensive deployment of VRE, primarily wind and solar, supported by advanced inverter and converter architectures and AI embedded control for forecasting. These technologies improve grid stability, optimize dispatch, and enable large-scale integration of variable resources essential for decarbonized power systems. Next one, please. Power electronics and power semiconductors are key enablers of decarbonization and sustainability. They can support one, efficient integration of renewables in the generation phase, two, high efficiency conversion, long distance transmission, and regenerative energy use in the transmission and storage phase, three, electrification by inverter converter based systems in the consumption phase. In short, power semiconductors make energy conversion and control possible across the entire electricity chain. Next one. This is a simplified diagram that illustrates how different power conversion are achieved using power electronics and semiconductor technologies. Over the past 50 years, the development of power semiconductors has significantly advanced power electronics for conversion processes. Key contributions include enabling high power application, improving efficiency, facilitating precise control, reducing weight and size, supporting the transition to renewable energy. As shown in the diagram, there is always some power loss during the conversion process, which affects overall efficiency. A major challenge in the pursuit of decarbonization and sustainability is minimizing these losses to enhance efficiency of power electronic system. This improvement is essential for broadening their implementation in energy uses within our society. Next one, please. Next slide. A high voltage direct current HVDC system using voltage source converter VSCs illustrate the active role of power electronics. Regarding efficiency and cost, HVDC VSCs reduce energy losses and are more economical for long distance power transmissions, typically over 600 kilometers. Regarding environmental impact, by enabling large-scale transmission of renewable energy, they significantly lower CO2 emissions. Regarding grid benefits, HVDC VSCs enhance grid reliability through redundancy, offer long operation lifetimes, and improve overall system flexibility. In short, power electronics in HVDC systems efficiently deliver clean energy over long distances while supporting a resilient, sustainable grid. Power electronics play a vital role in enhancing railway electrification. The key functions of power electronics include: 1. Optimizing motor speed for improved performance. 2. Enabling the motor to function as a generator during deceleration, allowing for the regeneration of power back to the overhead lines. This technology, which is based on high power semiconductors such as high voltage IGBT modules, contributes to more efficient, reliable, and eco-friendly energy distribution essential for modernizing and improving railway systems. In other words, advanced power semiconductor-based power electronics for railway electrification should continue to expand globally, more essentially in India. Power electronics are vital for electric vehicles, enhancing efficiency, performance, and driving range. Car manufacturers aim to cut CO2 emission by over 50% by 2030, highlighting the need for cleaner energies. The IEA predicts that the global electric vehicle must exceed 250 million by 2030, with EVs making up 67% of new car sales, up from 14% in 2022-2023 years. Power semiconductors are crucial for meeting these goals as their efficiency impacts energy savings and motor performance. Silicon carbide SiC devices are particularly effective for new inverters and chargers. By 2027, the automotive sector is expected to use 79% of the world's semiconductor SiC-based semiconductors capacity, indicating a rapid shift to this technology. Room air conditioners demonstrate the importance of power electronics in modern technology. These systems control energy use and improve performance, making appliances work efficiently while saving energy for users and environment. Switching from a fixed speed non-inverter air conditioner to an inverter type unit can save up to 58% in energy cost, providing a significant opportunity for national savings. This is especially crucial for countries like India, where the air conditioning use is expected to grow tenfold by 2050, making high efficiency inverter systems necessary. Future air conditioners will increasingly use advanced SiC MOSFET based inverter technologies, which offer better efficiency and compact performance. These innovations will be key to sustainable energy management in the future. Mitsubishi Electric's current power module portfolio, which positions it as a significant player in the market, offers a wide range of voltage and current capabilities, as various packaging structures. This leads us to a crucial question: what's next from Mitsubishi Electric in the new era of power electronics? The next few slides I think you will briefly answer this question. Next one. This slide illustrates the technological progression of silicon IGBTs on the CSTBT platform. Earlier generations improved performance through finer train structure, carrier stored layers, and drift layer thinning, which collectively reduced conduction and turn-off losses. The next step, CSTBT Generation 8, introduces a split gate structure, further drift layer thinning, and a deep buffer layer design. These features enhance switching behavior, particularly ion control, while maintaining effectiveness. As shown on the right, Generation 8 achieves a superior trade-off between DC loss and switching loss, continuing the historical trade-off loss reduction across the different CSTBT generations. Overall, the Generation 8 architecture provides a higher efficiency and application-tailored switching performance. Next one. This slide outlines the evolutionary roadmap of silicon carbide MOSFETs, or silicon carbide metal oxide semiconductor field effect transistors, based on an innovative trace gate platform. Generation 8 introduced a trace gate structure with engineered POL and PAL features that reduce electric field strays, feedback capacitance, and on resistance. Generation 5 advanced this by implementing finer design rules and increased cell density, resulting in a further reduction in on resistance. The upcoming Generation 6 will adopt a superjunction structure with implanted NP pillars, expected to be another improvement in specific on resistance. As indicated in the graph, each generation achieves significant on resistance reductions, 25% from Generation 4 to Generation 5, with additional reductions projected in Generation 6, enhancing efficiency for devices rated to 1200 volts. In conclusion, the development of silicon carbide devices is rapidly progressing, supported by ongoing structural innovations to improve system-level efficiency. This slide presents an overview of the current trends in power semiconductor module packaging technology. The advancements are occurring along three major axes based on the initial case-type structure shown on the left. One significant development is the transfer molding technology, which has led to the creation of the DIP IPM, dual inline phase intelligent power module family. These products are now widely regarded as the standard solution for home appliances. Additionally, the integration of cooling fittings has resulted in higher power density and increased robustness, making these designs particularly suitable for the next generation electric vehicle EV powertrains. In summary, Mitsubishi Electric is focused on developing most efficient or effective packaging solutions tailored to specific application needs and modernizing them through these three core axes. Next one, please. Okay, with that, I would like to show you a video showing Mitsubishi Electric's new modules and new development products.
Over the years, Mitsubishi Electric's semiconductors and devices have evolved to make life more comfortable, convenient, safe, and enriching in all kinds of situations. Moving forward, this evolution will continue to gain momentum. Facing the various social issues prevalent in the world today, we will exceed boundaries with uniqueness and technical prowess. To realize a bright future for all the people who call planet Earth home. Leading social change through the evolution and innovation of semiconductors and devices.
Okay, that brings me to the conclusion. I have listed 5 items here, but I've already explained most of them, all of them in fact. But just would like to point out the item 3 here. Make in India initiative should emphasize more on spending domestic hardware technologies at par with the advancement in power electronics and power semiconductor technologies. That ends my keynote speech. Thank you very much for your kind attention.
Thank you so much, Dr. Majumdar. And now for our keynote by our guest of honor on Indian power electronics industry, vision and immense opportunities. We are honored to have Ms. Sunita Verma, Group Coordinator R&D, Joint Secretary, Ministry of Electronics and IT, Government of India. Ma'am, I request you to please come up on stage of the dais, and can I have a round of applause, please?
A very good morning to all the dignitaries on the dais and off the dais. After such an insightful keynote from Dr. Majumdar and his concluding remarks that what India should do, I think we are totally in sync. And with Dr. Sai Baba, Ministry of Electronics and Power, to see that power electronics is one of the most important areas in which we venture and make a mark. I think the PCIM coming, Asia coming to India itself, I think, is one of the significant moves which shows that we are ready to embrace and go for the technology development and self-sustainability in the area. As I think our introduction has already been given on the importance of power electronics, the benefit, it being the backbone of all the electronic components and infrastructure, which is part and parcel of our life. And what we are striving at is carbon neutrality and improving the efficiency of power efficiency of all the systems which are developed. India is a growing economy, and the requirement and the buying capacity of our citizens is increasing. More and more appliances, gadgets at the personal level and also for the infrastructure development of the country require such solutions at home level, at power consumption level, for the data centers and other requirements that we have. Some of the reports project India's power electronics market potential to cross about 7.64 lakh crores, which is about $91 billion by 2033. Which will be driven by high growth of sectors such as battery energy storage systems, renewable consumer electronics, EVs, healthcare, data centers, while our exports CAGR of 15% signals India's emerging global competitiveness. METI has been supporting, so I head the R&D group in the Ministry of Electronics and IT, and the R&D support for power electronics was recognized way back, I think somewhere in the 90s, and we started the National Mission on Power Electronics. which is one of the flagship initiatives of R&D. And this has resulted in design, development, and deployment of and commercialization of power electronics technologies for enhancing the indigenous R&D expertise and the solutions, with the collaboration from industry and academia, also the R&D organizations. So in the stalls you can see is a stall from the ministry where we have our R&D society CDAC exhibiting some of the products which have been developed and commercialized. And also we have Indian Institute of Science where we have supported the GANFAB, a pilot D-line of GANFAB. So under the NAMPED, about 15 technologies have been designed, developed and commercialized in the areas for renewable energy, smart grid, high voltage power electronics for railways and microgrids. Ministry also has a program for electric vehicle subsystems. As the previous speakers have also said that with the growing demand, the converters would be one of the areas in which the efficiency of the converters and plugging the power losses is something that we need to look at. And METI has been funding the research in this area. In the EV sector, we are funding the motors, controllers, battery management systems, and along with the close industry participation. And when we say industry participation, there is some contribution coming from the industry and from the ministry together, so that, and it is totally industry driven. So this is initiative in R&D which is taking up. I feel there is a lot more to be done. I would request the power electronics sector industries to work along with us for the indigenous development or Make in India initiative that we have in this area. As you all know that the India Semiconductor Mission, which was launched with a 76,000 crore outlay, one of the areas for the fab that we are looking at is power electronics, silicon carbide or GaNFABs. And there are 10 proposals which have been approved under the ISM, and the one which we are looking at is for one of them, it will be for the silicon carbide. And this will be for our production and manufacturing of power components and power devices within the country. Under the India Semiconductor Mission, we also have a design-linked incentive, as Dr. Majumdar had pointed out in his address, that semiconductor, power electronic semiconductor is one area in which there is a need for working. And the design-linked incentive of the India Semiconductor Mission supports startups and industry for power ICs, for silicon carbide, GaN, and other power management ICs or other components at the chip level where we can make a mark. So this complete support, which is with respect to the tools, the lab, and also the manpower and other R&D efforts which are supported, will be in one of power electronics is one of the areas that we are looking at under the design linked scheme for taking up some critical infrastructure ICs. These programs, all the programs that we are looking at, and of course India, METI also has a AI mission, where we are looking at compute capacity, increasing the compute capacity in the country. And whenever we look at data centers, the power issues and the power requirement will surge in the growing years, and the solutions for having a power efficient technology is something that we are working on. All these initiatives of the ministry, we are towards developing indigenous value chain within the country, strengthening whatever is already existing and venturing into new areas, for right from the materials to the semiconductors and to the fab for manufacturing, along with the global value supply chain that is available, and our presence in that area. The collaboration for the next gen areas which will shape the future, ranging from the high efficiency converters, the grid forming technologies, advanced power electronics for battery storage, the green hydrogen, intelligent EV propulsion, and fast charging solutions, to high voltage semiconductors and packaging innovations, along with thermal management and reliability. Because success of all these domains will help India in moving confidently towards the net zero and energy secure future. The government and industry collaboration is very crucial for such initiative, and we are looking forward to working with the industry. We have been working, and we want more and more contribution coming from the industry, and government is there to support with respect to the policies, with respect to the fiscal incentives, with respect to market access. Together, as whole of a government approach with Ministry of Renewable Energy, Ministry of Power, Ministry of Electronics, we are all working towards this goal. And I urge all the global partners who are here to leverage India's scalability, our engineering talent, and the policy support to co-create advanced solutions that will prioritize the resilience, sustainability, and affordability. And we are committed towards India being a trusted partner in the supply chain for this area. I was told that this is the third or fourth PCIM which is happening here in the country and it's the first time it is here in India. And I'm looking forward to that, this conference being in India, and maximum participation is from the Indian companies, the researchers, and the R&D organizations. The round tables and the discussions, the exhibitions would help us in taking back some good collaborations, some good thoughts for our product development, and also working towards the national effort for the self-sustenance. We are also looking at the next phase of our national power electronics mission, which will be more ambitious and in sync with the national perspective for the semiconductor initiative in the power electronics field, and also the upcoming fabs that are proposed in the compound semiconductor area. I extend my warm wishes and success for this conference, and I wish that we will have very good and useful discussions that we can take advantage of, and it will be a benefit for us in future, for shaping India's future. Thank you.
Thank you very much, Ms. Verma. And now for the inaugural keynote address, by our chief guest on transformation and upgradation of Indian power T&D sector and smart grids, opportunity for the power electronics industry. We welcome Dr. D. Sai Baba, Joint Secretary, Transmission and Coordination, Ministry of Power. Can I have a round of applause, please?
Thank you. Distinguished members of the dais, and good morning to all the distinguished colleagues here, industry leaders, international experts, representatives from the academia, deputies and members of the power electronic industry. It's my privilege to join you today, and I'm thankful to the organizers of PCIM Asia Conference for inviting me to this inaugural session on a theme that is very central to India's energy future. We already have heard of Dr. Majumdar and Madam actually what the initiatives being taken by the government of India. So I just try to pitch in from the power sector what we are looking for actually. So as a part of the government, actually I am interested in the responsibility of the power transmission sector. So I am looking very closely, and I see every day how rapidly our sector is evolving, and how critical the role of the technology, especially the power technology, the power electronics has become. And we have already seen in one of the slides like where we are going for HVDC, that is what we are looking for. The HVDC is right now a technology which is still imported actually. We are looking for it to be indigenizing. That is the efforts we are making with MITI. And Madam Juntha Verma and ourselves, we are actually working as a close team to get this thing realized actually. So when we look at the Indian power sector, it's presently been a historic turning point. It's undergoing a major significant transformation since our national independence. We have seen since last decade how the rapidly expansion of transmission corridors have happened. And now there's a strong push towards 24/7 quality power, renewable energy integration and digitization of both transmission and distribution networks. Today we operate one of the largest synchronous grids in the world. We say one nation, one grid and one frequency. Our national transmission network expands today approximately 5 lakh circuit kilometers of transmission line with around 1400 gigawatt amperes transmission capacity, and our interregional transformer capacity, this transfer of has increased nearly 4 times in last 10 years, and today we are at 120 gigawatt of power can be transferred from one corner of the country to another corner. So, but the journey ahead is also more challenging and exciting, as the transmission sector's mandate for the next decade is very highly ambitious. We are looking for integration of 500 gigawatt of non-fossil capacity by 2030, and development of the high-capacity transmission corridors for renewable energy zones. Like we say that there is no transition without transmission, and with that logo, with that motto, we are working on that. And acceleration of the ISTS project through faster planning and approval process. A lot of regulations or the changes have happened in our system so that we are able to work towards achieving that goal by clearing the proposals faster. Extending the cross-border connectivity in neighboring countries. Today, we are aiming for almost 20 gigawatt of cross-border by 2030. And evolving the grid to handle high renewable penetration, EV loads, green hydrogen and distributed generation. The government's mandate is very clear: to build a secure, reliable and future-ready transmission system that can support India's economic growth while meeting the net zero commitment. So it may not be possible with the conventional technologies alone actually which we are seeing. High renewable penetration brings new challenges, especially such as the variability and intermittency which we all understand from the demand for stability and reactive power support with ever-increasing cyber-physical vulnerabilities. So traditional grid design is no longer sufficient. We will evolve from a mechanical grid to a digital and electronic grid. This is where the smart grid, power electronics, automation and digital intelligence will shape the future of India's T&D sector. Talking about power electronics from a transmission sector perspective, power is no longer a support technology, now it has become the core grid enabler. And we are viewing from that point of view. So power is almost everywhere at the power transmission level, be it the STATCOMs, which we are now getting into in our systems, SVCs, FACTC devices, which are now essential for voltage regulation and stability. The HVDC system with converter station that allows bulk renewable power transfer across long distance with minimal losses, grid forming converters that help in maintaining system stability as synchronous generation reduces. Because we can see that actually our concentration of the RE is mostly in states like Gujarat and Rajasthan, for which we already exhausted our AC systems to a large extent. So now the next option only available to transfer the power out from those areas is HVDC. As Professor Madhavan clearly explained that more than 600 kilometers, that works out to be much better, the losses are low and they're much cheaper. So that is why when we come to HVDC, then again this power electronics part where we're looking. As I told you in the beginning, like we are only importing, so we are looking for indigenization that, and that we have really a big scope, almost we are anticipating almost by 2 lakh crores worth of transmission systems are in pipeline for the HVDC systems alone. And our investment plan is almost 9 lakh crores up to 2030. So I'm talking rupee terms actually. Okay. And power plant plays a very key role, and using the power survey system in battery storage has been told, fast charging of EVs, power conditioning systems for electrolyzer under the green hydrogen production ecosystem. But you can say that India's clean energy transition is fundamentally driven by the power electronics transition, enabling a smart, responsive and customer-centric grid. And the vision of Atmanirbhar Bharat, the government of India has placed a very strong emphasis on domestic manufacturing through PLI scheme, revised PMA policies, Make in India procurement framework and support for semiconductor electronics manufacturing. To say MITI has been exceptional in implementing this vision of government of India's perspective. There is an enormous expansion ahead in the transmission sector. The power electronic industry is a vast opportunity to localize the production. We are committed to encouraging domestic manufacturing in the interest of power quality, reliability and grid compliances. As part of our localization efforts, we are encouraging the industry to increase the local content in components such as converter walls for HVDC, transformer bushings, etc. by R&D and technology transfer arrangements to achieve self-sufficiency and import substitution. From this platform, I can urge the industry players to invest in R&D and design in India, global standard testing and validation facilities, because we are even looking for a 1200 kV AC system. For that, again, we need to go for the testing systems for that. That will be one of the unique features of having a 1200 kV AC system. Component level localization and skilled manpower development. And MITI has already come forward to help us in these initiatives. So as a jointly with MITI and the Ministry of Power, we are looking forward for making this ecosystem in this country. The government is ready to support through productive policy, demand visibility and long-term planning framework. And I would like to touch briefly upon what India's power grid would likely to be in the 2035, what is our vision on that. It's a fully digital, highly automated transmission system, wide deployment of STATCOMs, FACTs and HVDC links, digital substation across ISTS and major state networks, integrated control centers operating with AI-assisted decision making, seamless renewable integration with real-time forecasting, a strong and a stable pan-India green energy corridor, grid readiness for large-scale EV adoption and hydrogen production, and a modernized distribution sector with significant reduction in losses and risks. So this is not just an aspiration, but it is all implementable. We are all working toward that to get these goals, and we look forward support from the power electronics industry, and I would like to make them as one of the critical partners actually in making this vision a reality. To all the industry leaders, innovators and students present here, the next decade will define the India's electricity future. We have the opportunity to build one of the world's most modern, reliable and intelligent power systems, and the power electronics industry will be at the heart of this transformation. Let us seize this moment. Let us commit ourselves to innovation, resilience, sustainability and nation building. And I am just repeatedly looking at the quote which is there, the agent of change for the India's power electronics PCIM. So maybe the PCIM should look for what has been there in the motto there. And I wish the conference a great success and look forward for the ideas, collaborations and takeaways that will emerge from this deliberation over the next 2-day sessions. And have a good stay in Delhi. Thank you very much. Thank you.
Thank you so much, Dr. Sai Baba. And with that, we come to the end of the inaugural session. I would like to, of course, thank our chief guest for sharing his thoughts and insights with us. I would like to thank Ms. Sunita Verma, Dr. Gaurav Majumdar, and Dr. Leo Lorenz for your thoughts, your insights, your solutions, and most importantly, the Government of India's vision for this very, very important sector. May I now request Mr. Raj Manik, and may I please call upon Ms. Petra Harberger to please come up on stage to felicitate our dignitaries on stage. A felicitation to our chief guest, Dr. D. Sai Baba, Joint Secretary, Transmission and Coordination, Ministry of Power. Thank you so much. To Ms. Sunita Verma, our guest of honor, Joint Secretary, Ministry of Electronics and Information Technology. Dr. Gaurav Majumdar, IEEE Fellow, Senior Fellow, Mitsubishi Electric Corporation. And to Dr. Leo Lorenz, President, European Center for Power Electronics. Thank you. I request all of you to please get together for a group photograph. Ladies and gentlemen, we will now take a short break for tea, but I'm sure you all know, but I would like to inform you anyway, that the conference program continues in two parallel tracks. This is the Bheem Hall, and then there is an adjacent Nalanda Hall. So you would have received the agenda in your brochures. So according to your interest, you will move accordingly after tea. All those who are participants in the high-level closed-door roundtable are expected to reach the boardroom on the second floor at 11:20 a.m. sharp. Please do not be late. And while you're outside having your tea or coffee, you will hear a bell, which means that the sessions have started. So that is your cue to please come back in whichever hall you would like to participate in, Bheem or Nalanda. And of course, for the speakers, be very careful and mindful of where you need to be. And I will see you here exactly at 11:30 a.m. Thank you so much, ladies and gentlemen.